Good afternoon. Hello. And I'm going to go ahead and give you all the code. We're going to be in Pear Deck today. Our old friend. Hello, everyone. Good afternoon. Happy Thursday. Next week is March, which is kind of hard to believe. Hello. All right. So good afternoon and welcome. The Pear Deck link is in the chat. And if you just click on it, we're going to start right away with a little icebreaker. I have had that Fortnite song in my head for the last 24 hours, and it made me think or wonder what songs or phrases or catchphrases or anything are living in your head rent free right now. For me, it's that Fortnite song. I'm not going to sing it or play it because I don't want to subject you to that, but I think you know what I'm talking about. So go ahead and click on the link. Go ahead and answer the question. Either a phrase, a saying, a song that's just living in your head rent free at the moment. Answer in our friendly neighborhood Pear Deck. Hello. Of course. All right. Hello. It's great to see you all. Good afternoon. All right. So I have 6 responses so far of 13. But I have 21 students on the call. So let's hear what you have to say. I'm not going to read all of them. Just want to know. I'm just curious. And it doesn't even have to be a song. It could be anything else that you like, a phrase, a catchphrase. And it's okay if there isn't anything. I'm just curious because that's been in my head for quite a while. And I honestly want something to replace it, is really why I'm doing this. Okay, thank you. Yeah, that's the one. Yes, that's the one. Oh my gosh. That's the one. The whole thing. And I honestly, I don't know why it has that power. I don't know. I don't know why some songs just have the power to get into your head. It's that Fortnite song, you know, the one. Someone actually put it in their yeah, that's the one. Yes, exactly. And I don't, yeah, and I don't want to, I almost don't want anyone else to see it because I don't want you all to suffer like I'm suffering. All right, about 10 more seconds. Ice break it. And then I just, you know, whatever. I've been kind of like it is so catchy and I don't understand why. It's so silly. Okay. But all these other songs like Metallica and all these other songs by people I don't know, I'm gonna try to replace this song with all of those tonight. Yeah, I don't know what it is. Something Tomato Town. I don't even know. All right. Thank you all very much for that. And I'm hoping that this will be the antidote for me. It's so catchy. Okay, I'm going to go ahead and press forward in the slides. And we're going to go ahead and I just want to lay out some things for what's going to happen today. So here we are. We are out of Unit 3, Topic 1. We are out of it. It seemed like it lasted forever, but we're moving on to Topic 2. So Topic 2, Unit 3, Topic 2 is all about inverse trig functions. So we're going to start today with looking at, what does inverse trig even mean? What does it look like? What's the purpose of it? What do we have to deal with to work with inverse trig? So today we're just going to construct the inverse graphs of sine, cosine, and tangent by restricting their domains. So we're starting with the icebreaker, which we already did. We'll do the warm up. And then we'll take some notes. You'll get a brain break. Then we'll do some practice. You'll have a chance to work on your homework or formative, and then we'll do an exit question, just like a summarize of class and an exit question. Reminder that you all have week 4 homework and week 4 formative due at the end of the week, or the end next week, so next Wednesday. And things from week 3 were due yesterday. If you turned it in by like 4 o'clock yesterday, I think it's been graded, but otherwise I'm still getting to it. So don't worry, I will be on it. And then for materials today, we'll do Pear Deck Zoom side by side. It says Nearpub, but it should say Pear Deck. The capture sheets are in modules, or you can take notes with pencil and paper. And then just a couple of quick announcements. So interims, somebody asked me last week when interims are. There are 312. So 2 Fridays from today, not next Friday, but the following Friday. And then progress checks, there was a mistaken announcement in your homeroom that their progress checks were yesterday. They're not, they're March 24th. So the progress check will be March 24th. Okay. And then the last thing is that some of you who had me last semester know this already, but if you have me this semester for the first time, some people are turning in homeworks that are like halfway done or missing sections. In order to get a 10 out of 10, it has to be a complete and reasonable attempt at every part, right? So sometimes if you miss a dot on a graph or something, I'll still give you the full 10 points, but some folks are turning stuff in, and I'm sure it's accidental, but like entire sections are missing. Please make sure that you complete your homework before you turn it in. Otherwise, I'll give it back to you and say, please complete it. Okay. Aren't photos due this Friday? I don't know. Are they? For yearbook? Yeah, I don't know about photos, so you'll probably find out in homeroom tomorrow though. But if we have time while y'all are working, I'll check. Do I post answer keys to homework? I do. So the homework answer keys are in the modules resources section. So if you go to MIME CPS Classroom, you know how every week we have a module. So the resources page is the one that's going to have the homework key. So that's where you should be able to find it. And if not, let me know and I'll fix it so that you can see it. Anything else? Any other questions? These are good questions. Anything else? Of course, you are welcome. All right, so make sure if you haven't already joined that Pear Deck, make sure you're in. And I'd like you to go ahead and give the warm up a try. So use the graphs of sine, cosine, and tangent functions to answer just one question, actually. State the domain of each function. State the domain of each function for me, please. What's the domain of sine? What's the domain of cosine? And what's the domain of tangent? All right, take about another 30 seconds. Almost there. Some of your domain signs are cute. They look like you have a sad face. Very cute. Oh, okay. Okay, so I'm going to go ahead. Great job. I love the way that you all are so creative with your notation. By the way, like the way people are making all real numbers and domain signs. Very cool. I love it. All right. Let me just see. All right. Okay. All right. Let me go ahead and proceed. I think we either have it by now or we don't. So let me go ahead. So here is the answer. So the domain of sine and cosine functions is all real numbers. So if you typed negative infinity to infinity, if you typed, that R with a double bar on it, you're good to go. Sine and cosine have a domain of all real numbers. So great. And that actually was an answer that most people got. Some people even started doing the range, -1 to 1. Awesome. Great. You didn't have to do that, but great. For tangent, tangent's a little trickier. So for tangent, every pi over 2, there's an asymptote. So the domain of tangent is the set of all real numbers except every pi over 2. And so that notation that you see there, x is not equal to pi over 2 plus k pi for all integers k, basically means that there's a discontinuity every pi over 2 on the pi over 2s. Okay. All right. So what questions can I answer about this? Anything at the moment? You can put any x into sine or cosine, but pi over 2 for tangent would be an asymptote. Because if you think about your unit circle, that's where your y over x would be 1 over 0 or -1 over 0 at pi over 2 and 3 pi over 2. Okay. All right. So let me turn my phone ringer off because it's super loud. What is a function? So a function is a relation that, sorry, it's just so loud, so loud. So a function is a relation between two sets that associates every element of the first set x to exactly one element of the second set y. So we have on the left side are examples of three functions that pass the vertical line test, right? Every x only goes to one y. So 3x, right? You see a graph there, 1 over x squared. Functions can look pretty goofy, but as long as they pass the vertical line test, right? None of the x's are cheating. You're okay. You have a function. On the right, you have examples of non-functions. Those are functions that fail the vertical line test. So if you drew a vertical line through a circle or a sideways parabola, you'd touch the graph more than once. If you even look at this parabola right here, see where x is 2, you have 2 y values. So x is actually, seeing both of these y values, right? Same with the circle. At x equals 0, you have a point at 4, but then you also have a point at -4, right? And then even here with this little line or this little graph here with all the blue dots on it, you see how there are a couple of places where x has multiple y values, right? So that makes these not a function, right? So they're all relations, but only the ones on the left are functions because the elements of x correspond to exactly one element of y, not two. Okay. Any questions about that, about what makes a function? Okay. Couple more examples of what a function and non-function would be. So on the left, you see that actually looks like a trig graph, doesn't it? Somewhat. It could be a sine or cosine graph. So that is a function. It passes the vertical line test. The sideways parabola and the oval or ellipse, I'm not sure what shape this is, either an oval or an ellipse. These are not functions because you can see that for graphs 2 and 3, they fail the vertical line test. Your x's are mapped to multiple y's, not a function. All right. Another little bit of a review, what is an inverse function? So we've talked about these in algebra 1, algebra 2, and again, now in pre-calculus, right? It undoes the original. So one way to find an inverse function is to switch x and y. So here we have a parabola. It looks like that's actually f of x is actually y equals x squared. And then we have the inverse. So what do we do to get the inverse? We can switch the x and y values. So 0, 0, 1, 1, those stay the same. But then you see that the bluish black function f of x has a point at 2, 4, whereas the greenish, the inverse function has a point at 4, 2. 2, 4, 4, 2. You just switch x and y to get your inverse. Okay. All right. So with all that being said, I want you to try sketching the inverses of sine, cosine, and tangent. Okay. I'm not going to expose anyone's answers. I just want you to try. Like, what happens when you switch the x and y values for sine, cosine, and tangent? What would the graph look like? All right. So take a few minutes. If you want to make a table, you can. But I just want to see what the inverse looks like to you, how you would visualize it. This is hard to do. I just want you to get a sense of it. And it doesn't have to, I just want you to it doesn't have to be perfect. I'm not expecting you to get it all right now. I just want to see how you approach it. So it's not about getting it perfect or right. It's just, I want to see how you're thinking about it. Take another like 30 seconds or so. All right. So let's go ahead and take a look. All right, so this slide shows you what the full inverse relationship is. So if you switched all the X and Y points on sine, cosine, and tangent, you would get that pink graph. So take a look at this slide. I just want you to let it sink in. If you switched the X and Y values, you would get those pink graphs. Take a look. So taking sine, for example, that's the one all the way on the left. If you take sine, you can see sine is at 0, 0. The inverse would also have a point at 0, 0, right? Because if you switched X and Y, you switched 0, 0, you would still have 0, 0, right? For pi over 2, 1, which is one of the critical points on the sine function, you'd have 1 pi over 2, which is this little guy on the right side. Then you'd have sine gives you pi 0. So then this y-intercept up here for the pink function would be 0 pi, and so on and so forth, okay? Cosine is very similar, right? Cosine starts at 0, 1, right? So the inverse has a point at 1, 0. Cosine also has a point at pi over 2, 0. Or pi over 2, 0. And then the inverse would have a point at 0, pi over 2, and so on and so forth. And you can see how since inverse functions reflect over y equals x, that's the switching x and y part, you can kind of see how the pink and the black functions would be mirrors of each other over that line, okay? And then same for tangent, right? All the vertical asymptotes are now going to be horizontal asymptotes. So whereas before your pi over 2s were off limits for x, now they're off limits for y. We have range restrictions now with inverse tan instead of domain restrictions, okay? So let me just let you process this a little bit more, take a look at it. Okay, now, remember the definition of a function that we talked about at the beginning of class. So yes or no, are the inverse sine, inverse cosine, and inverse tangent functions, are they functions? I shouldn't have, so are they functions? Are the pink graphs functions? You can put it in the pear deck slide, or if you're having trouble with the pear deck, you can just chat it to me. Take about 30 seconds to answer. Yay or nay? All right, I've got 18 responses, but there are 25 people in the class. So get your best guess. No one's going to make fun of you, or the only person who's going to know your answer is me. So give it a whirl, give it a guess. It's okay to be wrong. It's better to try and be wrong than not try. Are the pink graphs that you see here, are they functions? Do they pass the function test? All right. So the answer is no. They are not functions. None of the functions, these functions are invertible. And the reason is that we talked about this, right? Multiple elements of the domain are paired with a single range element. So when you invert it, right, you have a pink graph that fails the vertical line test. It does not satisfy the definition of a function, right? But we need to know values of inverse sine, right? Because that's how we're solving all those word problems, right? That's how we're finding when is the tide 12 feet? We're taking the inverse. So how do we deal with that? The way we deal with it is that we have to restrict the domain and the range, okay? So for example, let's take sine of x. So that highlighted portion, we're restricting that domain from -1 to 1, okay? With range, we're restricting the range to 0, 1. And then with tangent, we're restricting the range from -pi/2 to pi/2, because the domain is all real numbers for tangent, right? We don't have any domain restrictions, but for tangent, we have to restrict the range so that we don't run into this problem of running into the asymptote. So we only want to get like one cycle of the function before it starts doubling back on itself, okay? All right, so a key takeaway, and I'm going to repeat this again at the end of class, is that inverse trig functions, right, are just the trig functions, but switching x and y. So they're mirrored over the line y equals x. And we have to restrict their domains or ranges so that they will be functions. So right here, this is a key part of the lesson. This is a key takeaway, the new learning for today that is important for you to hold on to. Inverse sine, instead of having that pink wave, right, we're going to restrict it. So the domain goes from -1 to +1, and the range goes from -pi/2 to +pi/2. For inverse cosine, we restrict it so that the domain is -1 to 1, and the range is from 0 to pi. And then for tangent, our domain is -∞ to infinity, but we restrict the range to -pi/2 to pi/2. We are restricting the domain so that we can use it as a function, so that we can get actual values of x when we need to find, do those tide problems or do those sunlight problems or temperature problems, because we need to get some kind of value for our angle, okay? All right, so I'm going to leave you with that for a moment, and I want to go ahead, it's about halfway through class, I'm going to go ahead and give you that brain break. Let's go ahead and take 2 minutes, stretch, go to the bathroom, get water, do jumping jacks at your seat, and we'll go ahead and get started in 2 minutes. All right, so let me get you back. So that's kind of the key takeaway today is the inverse trig function graphs. We have restricted domains. They have very special shapes, sine, cosine, tangent. So what I'd like to do now is give you the opportunity to either work on this week's homework with the sinusoidal word problems or work on this week's formative, okay? I'm trying to limit your outside of class work. So I'm gonna go ahead and unshare. And you can choose what it is you wanna work on. And then, you can chat me questions as you work. We'll come back as a whole group in let's do like 15 minutes. So do 15 minutes and we'll come back as a whole group. Man, trying to make a copy of it. Will this work? All right, so if you're having trouble with like some of the word problems, I'm just gonna help you out a little bit with my terrible computer drawing. Yeah. So the length of the period can be kind of tricky. But I think it always helps to sketch a graph, even if it's like what I have, which is kind of a goofy looking graph. But let me erase it now because I think I'm writing on all your templates. So I'm going to erase it. Annotating is helpful too if you just like read the word problems. Oh, the other 10 hours. So if you go from low tide to high tide, that would be half the length, right? So you'd have to just go double it to get the rest of the rest of the way down. Because going from low tide to high tide would be half of a cosine wave, and then high tide to low tide would be the other half of the cosine wave. So if it varies sinusoidally, that means that however long it takes me to get from minimum to maximum is going to be the same amount of time it takes me to go from maximum to minimum. I'm so bummed out that I can't write on this Cami without changing what you all see. Yeah, the period is based on the context of the problem, but it's always going to be, it's always going to be symmetrical in that way. So going from low tide to high tide would be half of a wave. In problem 6, they just straight up give it to you. They say in problem 6, they just say it makes a complete revolution every 40 seconds. So it's just it just tells you that the period is going to be 40 seconds, and then that's all you need to worry about. And then it's easy to write it from there. And then 7 is a lot like 5, except 7 actually gives you a graph and has more, it's more like what the rest of what we did in class on Monday. Okay. Any other questions for me about the homework? All right, so with number 6, we have Brian riding in a Ferris wheel with a 60-foot diameter. And the Ferris wheel makes a complete revolution every 40 seconds. This is kind of like the algebra 2 problems you were just starting to get done right before the pandemic. So the 60-foot in diameter just means that that's sort of like from the minimum to the max, like how much distance there is as he goes around. The Ferris wheel makes a complete revolution every 40 seconds. So that means that your period is 40. After 12 seconds, he's at the top of the Ferris wheel, which is 68 feet above the ground. So we know that at 12 seconds, he's 68 feet above the ground. Write a sinusoidal function that represents the situation. Let t represent time and h of t represent the height. All right. So here's t and here's h of t. All right. So if the diameter is 60 feet, that means that the lowest he can get would be 8 feet, right? Because the whole length would be 60. Okay. So that means that we know what our max and min are, right? We know that we have a max of 68 and we have a min of 8, right? So then what would our midline be? Good, be 38. So the midline, exactly, good. The midline would be at 38. Okay. If we make a complete revolution every 40 seconds, that has to mean, so the period is 40. So that means that at 52 seconds, Brian has gone all the way around, right? So he's back up at the top after 52 seconds. Okay. So he's basically making a wave like this. This is the Ferris wheel wave. All right. We have an amplitude of 30, because remember, amplitude isn't the full height, it's half the height. So half the height is 60. We know that the period is 40. So B is 2 pi over 40, which we can reduce to pi over 20. Our phase shift is 12, because that's when our wave starts. And our midline, or our vertical shift, is going to have to be 38. So if we're writing our full equation, that's going to be h of t equals, what kind of graph do you think we're going to use? Sine, cosine, negative cosine, negative sine? What makes sense for this graph, do you think, given all the parameters we've discussed? Yeah, good. So I would say cosine, positive cos. So my amplitude is 30. We're doing cosine. We have our B is pi over 20, and then x minus 12, and then plus 38 at the end. Ugh, that looks like times 38. Plus 38. Plus 38. Okay. Yeah. Just think, like, if the top is 68 feet and the Ferris wheel has a 60-foot diameter, that means the bottom would be 60 feet. Yeah, 68 would be the max. Because remember, it's the diameter, right? So if 60 feet is the diameter, then if he's at the top at 60 feet, 68 feet, then the bottom would have to be 8 feet. 68 minus 8. Okay. So y'all are good with amplitude, period, phase shift, midline, writing equations. And then number 7 is like what we did on Monday. And that recording is up in modules if you need to rewatch it, but this is number 7 is like what we did on Monday. right, take about 3 more minutes and then we'll summarize and close.
Oh, it's bad. Can you go back to problem number 6 again?
Oh, sure. I erased it, but we can go back. Actually, this is probably a good opportunity for me to show you guys where to find the find your resources. So rather than do the problem again, I think this might be a good moment. So you all know where modules are at this point. You've become virtual learning experts. So in week 4 resources, we have the slide decks, the recordings. You can look at your takeaways from Monday's lesson that are individual to you if you want. And then the slide deck from today is here as well. The recording will be after class is over. And then this is actually the key to the homework. So you can check your work. So rather than kind of like redoing it, you could just kind of like check here if you want. So that's just something for you to see if you want to see it. All right. Do you all have any other questions or anything for the good of the group? All right, so let me go ahead and summarize. So in summary, we have to restrict inverse trig functions so that they will be functions, right? So remember, inverse sine looks like that, inverse cosine looks like that, inverse tangent looks like that. So when we switch x and y for sine, cos, and tan, we end up with a non-function, okay? And we need to fix it so that it is a function. So we do that by restricting the domain and range, all right? So what I'd like you to do on the next slide, I'll give you a minute to do this and think about this, is that there is a red star, an orange star, and a green star. So I'd like you to drag the red star to inverse sine, the orange star to inverse cosine, and the green star to inverse tan. So go ahead and take a couple, maybe like a minute or so to give that a try. I just want to see how much I need to hit this again on Monday. This is really the heart of the learning today. And you can use your resources. You can see what the graph looks like, look at your notes. We are in virtual learning. Everything's open note. Okay, I'm gonna lock everyone's screen in about 30 seconds. All right. 7, 6, 5, 4, 3, 2, 1. All right. Let's see how we did. Okay, so pretty good. So by and large, pretty good job. So orange is cosine. right? One way to tell is that cosine is the inverse cosine is decreasing. So if that helps, orange was inverse cosine, green was inverse tangent. And one way you can tell is there's no domain restrictions on tangent. So the fact that it goes all the way to the windows of X is helpful. And then red was inverse sine, and inverse sine is increasing. So very good. Okay. All right. So excellent work. Really proud of you guys. Good job today. I will see you Monday, or if you come for office hours, have a wonderful weekend.
Goodbye.
Bye.
Bye.
Thank you. Have yourself a great weekend. Elena, Joshua, do y'all have any questions for me?